can classify a benign lesion as being small, up to 5 mm in size, brown in color, symmetrical, and with regular edges. When referring to a cancerous or malignant mole, we refer to those that deviate from the normal parameters of a mole. One of the first signs of melanoma is the appearance of a new mole in adulthood, or changes in size, shape, or color of an older one. Not every asymmetrical mole is a cancerous one, but however, the presence of an asymmetrical mole on the skin poses a higher risk of skin cancer. On the screen, you can see some examples of benign freckles and malignant ones. The difference is pretty clear as stated before. Given that we're in a period of rapid technological development, we aim to use artificial intelligence to potentially detect cancerous moles and guide our users to more detailed investigations. It would be wonderful for us to imagine a world where people can perform periodic self-assessments of their skin lesions and moles. Moving on to what motivated us to create and work on this project. On the slide, we see the standardized rates of incidence and mortality of melanoma per 100,000 people years for both sexes combined. Although in Romania, the rates of incidence are pretty low compared to other countries in Europe, the rates of mortality are significantly higher than our neighbors. This discrepancy highlights a significant problem with early detection and treatment of melanoma cases. Moving on to the interface of our application. It is clean, intuitive, designed to facilitate easy navigation and quick access to information. With a clean color scheme and distinct visual elements, users can efficiently identify and access the desired functions. Each screen is logically organized, offering views and details in a way that does not visually or informationally overload the user. As for our dataset, we use the HAM10000 dataset, which stands for Human Against Machine, with 10,000 dermatoscopic images, and represents a comprehensive collection primarily used for training algorithms to differentiate dermatoscopic lesions. The dataset is intended for academic research and may be used in other works on the same theme and is publicly available through the ISIC archive. It includes a bit over 10,000 dermatoscopic images, each labeled by experienced dermatologists. The images represent a mixture of 7 different diagnostic categories. This variety supports the development and testing of automated diagnostic models in dermatology. Each image in the HAM10000 dataset is also annotated with metadata that includes the diagnosis of the lesion, the location of the lesion on the body, the patient's age, and the patient's gender, providing a robust basis for both academic research and practical applications in AI-driven diagnostic tools. For the photos that the user takes with their phone, we use the XGEN algorithm to enhance the image to be able to use it with our dataset. On the screen, you can see a small presentation about the 7 different types of skin lesions that are present in the HAM10000 dataset. In this project, we have chosen to use the ResNet-50 architecture, an advanced convolutional neural network, to catalog conditions from dermatoscopic images in the dataset. The main reason for choosing ResNet is its ability to manage very deep neural networks without encountering the problem of gradient disappearance. A common challenge in
Am o
training
singură
neural
mențiune,
networks.
faptul că în online nu se aude
Residual
această
connections, a
prezentare.
key feature of ResNet, allows signals to travel directly through the network, facilitating more efficient training and faster convergence. The first step was resizing the images. This is followed by labeling and pre-processing the data for training, including splitting them into training and test sets. A neural network is built using the pre-trained ResNet-50 model and trained on the training data. Finally, the model is evaluated on the test data to determine its performance in classifying disease types in images. By using a pre-trained version of ResNet and fine-tuning it to the HAM10000 dataset, we were able to benefit from transfer learning. This means that our model did not start learning from scratch, but adapting pre-existing knowledge to accurately recognize and classify different types of dermatological lesions. In our project, the ResNet-50 model achieved a remarkable accuracy of 93% on the test dataset. This high level of precision underscores the model's effectiveness in identifying and classifying various dermatological conditions accurately. Thank you very much for your attention.
We thank the speaker. The speaker is not online,
we will not have a Q&A session here. Mircea, you have questions? Or?
Aș avea mai multe întrebări către speaker. Întrebarea mea este cum vom evalua calitatea răspunsurilor la întrebări dacă el nu e prezent? Ca să fie ceva unitar, să nu...
Vom veni cu un răspuns unitar. Cred că e singurul care nu e prezent și cel puțin eu am văzut prezentarea video trimisă. Vedem, la finalul sesiunii putem să decidem împreună.
Ok, bine. Trecem mai departe atunci.
Da, mergem.